Generative AI refers to artificial intelligence models that generate new content. Unlike traditional AI, which focuses on analyzing or classifying data, generative AI produces original outputs such as text, images, music, and even code. These models rely on deep learning, specifically neural networks, to understand and replicate patterns in data. Essentially, generative AI learns the essence of its input data and creates new content based on that learning. Some popular examples include ChatGPT for text, DALL-E for images, and MusicLM for audio. At its core, generative AI uses neural networks. These are systems inspired by the human brain that process data in layers. The models most associated with generative AI are called transformer models, like GPT, which stands for Generative Pre-trained Transformer. These models use attention mechanisms to focus on the most relevant parts of input data. Advanced models like large language models, or LLMs, use transformer models to process and understand language contextually, enabling them to generate coherent text or other outputs. LLMs process data in small units called tokens, which can be whole words, parts of words, or symbols. The number of tokens they can handle at once is determined by their context window, essentially the model's short-term memory during a task. The process begins with training. During training, the AI is fed vast amounts of data. Think millions of books, images, or sounds. This data helps the AI learn patterns and relationships. For text-based models, like GPT, the AI learns how words and phrases are used in context. For image models like DALL-E, it learns how colors, textures, and shapes combine to form coherent images. Most popular generative AI models fall into two common types. Autoregressive models like GPT generate content step by step. Diffusion models like DALL-E, or Stable Diffusion, transform random noise into detailed images. In each case, the models use algorithms that predict what comes next. In a text model, the AI predicts the next word in a sentence. In an image model, it predicts the next pixel or pattern. But generative AI isn't just a tech novelty. It's a game changer across industries. In healthcare, AI is used to design new drugs or create personalized treatment plans. In education, it powers interactive tutoring systems. In entertainment, it's generating scripts, animations, and music scores. Game developers are using AI to generate complex environments and characters dynamically. It's also reshaping business operations, enhancing creativity, and improving productivity. But despite its potential, generative AI comes with challenges. Bias in training data can lead to biased outputs. Additionally, the ability to generate realistic fake content raises concerns about disinformation. Data privacy is another concern. Models are trained on enormous data sets, which may include sensitive or copyrighted material. To address these issues, developers, organizations, and individual users must prioritize transparency, ethical guidelines, and robust safeguards. However, there's enormous potential to make these models more efficient, accurate, and ethical. As this technology evolves, so too does our opportunity to shape the future.